Hello everyone, welcome to today's discussion on the Nutanix Distributed Storage Fabric. My name is Michael Jasted, and we'll spend the next 13 minutes or so walking through some of the elements and concepts of the storage fabric architecture. At the end of today's discussion, you should walk away with the ability to identify and articulate the relationships between storage pools, containers, and vDisks as part of the storage fabric or DSF. You should also have a detailed understanding of how the Nutanix distributed storage fabric appears to the hypervisor and guest file systems, as well as understand the various layers and the storage elements within each layer. And finally, gain insight on how storage is distributed and balanced across the fabric. So before we begin today's discussion, let's take a look at some of the building blocks that make up a data fabric, starting with the compute node. A Nutanix compute node provides the ephemeral storage, networking, memory, and processing resources that can be consumed by a virtual machine instance. It's a single system that participates in a cluster of many systems, and within the Nutanix cluster, compute nodes form the core building block. Again, they supply the processing, memory, network, and storage that virtual machine instances need, all of which is orchestrated using control logic operating as a software-based service on each node. So let's take a closer look at the components that make up a Nutanix node. We'll start with the node's direct attached storage, local to each node, which provides a faster performance and greater flexibility. Each Nutanix node contains flash-based storage to deliver massive IAPS for high-performance workloads, as well as hard disk drives for low-cost, high-capacity storage and archival. Node storage is auto-tiered, which is the progression or demotion of data across the different tiers or types of storage media. The movement of data takes place in an automated way with the help of control logic as a software-based service, also known as CVM. Data is pinned to the related media type based on the data's performance and capacity requirements and/or the frequency in which the data is accessed. The main or primary memory, combined with compute, together comprise the node's engine for control and data processing. A controller VM serves as the node's I/O controller. In the simplest term, the Nutanix CVM is the control plane for marshaling hypervisor VM I/O operations and orchestrating recovery during failover, data protection, load balancing, and data replication. And finally, the hypervisor, or virtual machine monitor, which is the software that creates and runs virtual machines. Having a single compute node operating within a Nutanix cluster doesn't really provide much of any benefit. The power of hyperconverged infrastructure is harnessed when additional nodes are seamlessly added to the cluster, distributing both compute and data across the managed environment. This web-scale approach provides the ability to scale as needed to meet the changing demands of IT workloads. Tolerance of failures is key to stable, scalable distributed systems, and the ability to function in the presence of failures is crucial for availability within the fabric. The Nutanix distributed fabric provides both the control and data planes, allowing a Nutanix cluster to expand and continue to function normally as one unit, avoiding performance bottlenecks and single points of failure. Techniques such as leader elections, multiple replicas, dynamic flow control, and data scrubbing, to name a few, are all core functions to ensure data resiliency within the fabric. Together, a group of Nutanix nodes forms a distributed system. All services and components are distributed across the CVMs in the cluster to provide a high availability and linear performance at scale. These techniques are applied to both metadata and VM data alike. By distributing metadata and VM data across all nodes and disks, we can ensure the highest possible performance and durability, as well as availability during normal data ingest and reprotection. This enables our MapReduce framework to leverage the full power of the cluster to perform activities concurrently. So let's take a closer look at the Nutanix Controller VM and its services, which provides the control logic packaged as software as a service. We'll start with Curator, which is built on a MapReduce framework responsible for managing and distributing tasks throughout the cluster, including disk balancing and proactive data scrubbing, just to name a few. Curator runs on every node and is controlled by an elected curator master, which is responsible for the task and job delegation. Curator Master coordinates work by running several scans across the fabric during its life cycle. A full scan occurs once every 6 hours, while a partial scan occurs once every hour. Another process, Zookeeper, stores all of the cluster configuration, including hosts, IPs, state, and so on. This service runs on 3 nodes within the cluster, one of which is elected as a leader. The leader receives all requests through an interface called Zeus and forwards them to its peers running or operating on other nodes within the fabric. If the leader fails to respond, a new leader is automatically elected and access to the cluster configuration data is resumed. Cassandra instances are accessed through a Medusa interface, and they operate cluster-wide. Cassandra instances are responsible for storing and managing all of the cluster metadata in a distributed ring-like manner, where there's a Paxos algorithm that operates on behalf of Cassandra to enforce strict consistency of the cluster's metadata. Stargate is responsible for all data management and I/O operations and is the main interface from the hypervisor via NFS, iSCSI, or SMB. This service runs on every node in the cluster in order to serve localized I/O. Genesis is a process which runs on each node and is responsible for any service interactions such as VM start or VM stop, as well as the initial configuration. Genesis is a process which runs independently of the cluster and does not require the cluster to be configured and or running. In fact, the only requirement for Genesis to be running is that Zookeeper is also up and running. And then finally, Pythos, which is responsible for vdisk or DSF file configuration data. And like Cassandra, Pythos runs on every node and is layered on top of Cassandra instances.